Good morning, everybody. This is Gary King, Sales Director of Trenchless Works magazine and media platform. Just here to welcome you to today's webinar, which is being held by RSM Lining Supplies and the Operations Director, Tom Waddups. Tom will be presenting today on resin of choice, and I'd just like to pass over to Tom so he can talk you through his presentation. Thank you.
Lovely. Thank you for the introduction, Gary. Good morning, everybody. I'm Tom Waddups, the Operations Director of RSM Lining Supplies. Just like to briefly thank West Trade, particularly Alice and Gary, for arranging this presentation today. As discussed, the presentation will be based around resin choice for CIPP lining. Just to give those of you who don't currently use RSM Lining Supplies or aren't aware of the business, a little overview of our position and our organisation. The business RSM was begun in 2003 by our current Managing Director, Richard Davis. Richard had a vision back in the early 2000s to bring choice and technology to our industry, but also to deliver proven products through technically proven personnel. That being particularly important, as it would revolutionise the customer service in the CIPP industry. Obviously, over the last 17 years, the business has grown substantially. The image on the slide is our current head office, but we also have distributors worldwide and an office in Sydney, Australia, supplying materials and equipment daily, both nationally and across the globe, making us, as we feel, a market-leading supplier in the CIPP industry. Over the course of the webinar this morning, following on from Phil's introduction to liner types and liner choice, we are going to be talking significantly about resin, looking specifically at the different resin options available through RSM Lining Supplies and across the industry, looking at how suitable they are to individual applications, the strengths and limitations of each product, and ultimately the aim is to give the listeners and yourselves a better understanding of the resins available for cured in place pipeline installations, their suitability, and ultimately to introduce you to RSM, if you haven't known us before, as a service that can assist you in speccing product and choosing the right product for each application. So, to give you an introduction, the resin element of any CIPP installation is one of the most important choices that the contractor or the engineer can make. It's an absolutely pivotal part of the cured composite. When we're looking at cured in place pipelining and forming a new structure within an existing pipeline, there are numerous things that should be considered. And the resin being a pivotal part of that, when we are looking at a certain resin for a job, we need to consider ultimately what our end goal is. So, are we looking at lining the pipe specifically to improve hydraulic characteristics? Or are we looking to reinforce the pipe to take any ground loading, for example? These considerations are particularly important when we look at both the liner choice and the resin choice. To give you an idea, we should consider the diameter of the pipe. We use different resins for different diameters. Larger diameter applications require more working time, have different loads upon them, and so we would choose different resins and different liners to suit those applications. We need to consider the length of repair. How much installation time do we need? Can we get the liner into place, the resin into the liner and into the ground and cured effectively? Length of repair is a pivotal condition upon which we need to consider. Are there any environmental hazards, for example? Does the pipe discharge into a river or a stream? do we need to consider how we can contain the resin within the liner or within the pipe during the installation? Another consideration is the effluent. Do we have any chemicals running within the effluent? Is there significant hydrogen sulfide attack due to the position of the drain amongst the system or close to a treatment plant, for example? On the back of these considerations, we would choose different types of resins based on their chemical resistance, based on their strength characteristics. And over the course of this presentation, we would like to give you an indication of all the different options, look at their strengths and weaknesses, and ultimately in the end, hopefully give you a better understanding about what to choose and where. We should also consider whether leak tightness is required. Polyester resins, for example, form a mechanical interference fit and can be designed to be standalone. Epoxy resins or silica resins form a leak-tight finish to the host pipe. When looking at the individual resins that we offer, we must say that we have a resin suitable for all CIP preprocessors. We also have a technical team that process all of our resins and test against the relevant ISO certification and standards prior to our resins going to market. Throughout the webinar today, we would like to give you a better understanding of the individual types of resins. We're going to begin with polyester resin, which is still the most widely used product across the globe. We're then going to move into the epoxy range, specifically our epoxy range, silicate resins, and more specialist resins, vinyl ester resin for chemical resistance applications, or for pressure pipe applications where a higher elongation at break is required to get the right mechanical properties. We're then going to look lastly at the UV and LED cured vinyl ester products and the benefits that that can have in revolutionizing your cured in place pipelining applications. The main function of each of these resins is still to combine with the current material to form a seamless, jointless composite. The secondary functions potentially are the capability to resist loads, the capability to resist chemical resistance, the improvement in hydraulic capacity, and the increasing lifespan of the CIPP liner and the increasing lifespan of the drain once the liner has been installed. Firstly, we're now going to move on to polyester resin. RSM lining suppliers offer a variety of polyester resin suitable for individual applications. Polyester resin has been the most commonly used resin within the CIPP industry over the course of time. The first installation of CIPP, conducted in 1971 by Wood, which would later become in situ form, used a polyester resin as the main basis for the composite liner to be installed. That liner is still installed and in use today, 50 years on. Initially, we're going to look at the hot cure process. The hot cure process involves mixing a polyester resin, usually a filled resin, as it holds in the liner material much better than an unfilled material. It also makes the material more cost effective. For hot cure installations, polyester resin is mixed with specific catalysts and accelerators, and it is impregnated in a factory setting in a controlled environment, usually into a needle felt liner. The needle felt liner can be glass reinforced. The needle felt liner is then stored in refrigerated transport until the liner is due to be installed on site. The liner can be dragged or inverted into place. It is suitable in most applications to go around bends, and it is also suitable in most applications to form a fully structural pipe within a pipe capable of withstanding ground loading. Hot cure applications remain the most flexible of liner installations. Little risk during the installation, and also suitable for most diameters, most pipe shapes, most pipe sizes. And the resin will not prematurely cure. The cure is only accelerated by the addition of heat, which kicks the exothermic reaction, cross-linking the chemicals and forming the basis of the composite, the pipe within the pipe. In smaller applications, we use an ambient cure system with polyester resin. Commonly, we mix a filled polyester with a BPO catalyst and accelerant. This gives us the ability to increase or decrease the pot life of the resin on site, dependent on the ambient temperature, the site conditions, or indeed the crew's ability. A very experienced crew may choose to mix the catalyst and accelerant, for example, at 5%, whereas a less experienced crew who requires more working time could use a lesser percentage, but ultimately achieving the same result just over a longer time frame. Ideally, the resin needs to be kept cool in an area away from direct sunlight for the impregnation, and the impregnation should be undertaken using a vacuum and also using pressure rollers, which are specifically measured to the liner thickness being installed. Obviously, the suitability of the ambient cure process is limited because you're limited to the point of the resin's cure time. It also has less control almost because you are mixing the chemicals on site. You're not in a controlled environment, and so you need to be particularly careful or cautious about the installations you attempt using the ambient cure process. To give you an overview of the hot cure and ambient cure process using polyester resin, we can use polyester resin with most of our cured in place pipe liner reinforcements. In terms of the felt liners, ambient cure can be used with the whole range of drag and inversion liners from Applied Felts and through ourselves, with flex inversion liners and superflex for going around 90-degree bends or for lining down downspouts. And using the hot cure process, we can also utilize polyester resin with our ferroforce liner. This not only increases the strength characteristics of the liner being installed, but it can also reduce thickness, maintaining and increasing hydraulic capacity of the finished installation. I'd just like to take you through some strengths and limitations of polyester lining in general. What we must say is that using the hot cure process and also the UV cure process, where polyester resin is impregnated into a glass fiber reinforcement with a thickening agent to hold the resin in the liner, the material has excellent mechanical properties when cured. This means that we can rely on polyester liners having a lifespan of well in excess of 50 years when designed correctly, and they're capable of withstanding any ground loading, train loading, live loading, and hydrostatic loading that we're going to put on those liners in the future. Polyester resin, by its very nature of having styrene as the main reactive monomer, is a cost-effective solution for drain repair. It's incredibly cheap when in comparison to some of the alternatives available. We must not forget that it's been used for so many years, and so the experience and wealth of information that we have on polyester resin leads it to being a very proven, safe solution for long length and short length, but also large diameter CIPP applications. The product does, however, have its limitations. Obviously, the product does contain styrene, which is a volatile organic compound. We must make sure that when curing the liner, we do so correctly to the manufacturer's recommendation to get the minimum residual styrene within that liner for the best mechanical properties, but also to make sure we have the minimal impact on the environment. We also have the issue that polyester liners do not adhere to the host pipe. They give a close fit, which we refer to as an interference fit, or a mechanical lock to the host pipe. This means that water can track behind polyester liners and find the next manhole or access point and get in behind the liner. That said, if the liner is designed properly, it will be capable of withstanding that water and any hydrostatic loading. In terms of the use of polyester, it's still widespread across the UK. We impregnate many large diameter polyester liners each day and have a refrigerated vehicle fleet to take them to any part of the UK and Ireland. But we must think about our environmental considerations and the good practice that we should have to ensure that lining using polyester remains safe and we control the effect of polyester lining upon all the stakeholders. So we should be alert to the human impact and the environmental impact when assessing each job. For example, it may not be suitable to install an ambient cured polyester liner underneath somebody's house because the styrene odour could vent up lateral connections and that could make them feel uncomfortable and it would cause a smell. We should carry styrene monitoring devices to protect our employees and also the customers to ensure that they're not exposed to higher levels of styrene than is absolutely necessary. The biggest thing that we can do to ensure that the styrene odour is minimised is to ensure that we have the correct post-curing of liners. Controlling our exotherm using heat leads to residual styrene odour being lower. And really, we should be aiming to have a residual styrene content of as low as 1% if liners are post-cured correctly. In areas where we have particularly concerning environmental considerations, we should perhaps use epoxy resins or styrene-free vinyl ester resins so that we're not exposing the environment to the effects of styrene. We can consider extraction, and we can also educate the customer so they know what to expect from the impact of our installations. We're now going to move on to looking at the various different epoxy products available on the market. RSM offer many epoxy products, but we're going to consider our pivotal range of 3 initially. These being 9052, 9204, and 9100-1, which is our WRC approved heat or steam cured epoxy solution. To give you a brief introduction to epoxy resin, epoxy resin is a styrene-free alternative to polyester. To most pipe types, it provides us a leak-tight alternative solution. So not only is it capable of improving the hydraulic capacity through installation of a CIPP liner, it is also capable of stopping infiltration to a greater degree than installing a polyester liner. We, as I say, offer many types of epoxy, and today we're going to talk through the pivotal range of 3 which cover most applications, initially looking at our ambient cured epoxy named 9052. None of the epoxy products offer a long-lasting odour. Once installed, they are completely inert, styrene-free of course, and odour-free, and have excellent chemical and heat resistance properties, each of which dependent on the type used, which we'll look at in a little while. To consider 9052, which is our ambient cured solution initially, it's an excellent product for repairing 100 and 150 millimeter diameter pipes, styrene free, and is suitable for use with our whole range of liners. The product has a varying pot life depending on the temperature, but we can get as much as an hour to an hour and 10 minutes out of the product if we chill it down, while still remaining while it's still remaining workable. The 952 product is particularly good for in-house lining of downspouts. It has a viscosity that enables it to hold within Superflex and flexible liners such as MagmaFlex and Echo Liner very well, and it adheres to the hose pipe. So it's particularly good for the relining of internal drains, downpipes, that sort of application. But it's also particularly good for lining underneath areas of human inhabitants. To look at the sort of strengths and weaknesses or limitations of this product, as we say, particularly good for lining underneath properties or within in-house applications. Good chemical resistance, up to around about 60 degrees. It's also compatible with our whole range of liners, and you get a leak type finish. In terms of the potential issues with using epoxy, obviously it is a little bit more expensive than polyester resin, possibly 2 to 3 times the price of the resin, but in terms of the whole CIPP installation, the costs are minimized. We don't have to consider things such as extraction or potentially letter dropping or anything like that, because we're not going to have the environmental impacts that we would with other products. The product can be accelerated in terms of the cure through the use of a hot box or small amount of hot water. Possibly one of the only other limitations with 9052 as a product is that in cold temperatures it can be a little bit difficult to work with, as if you can't get hot water there, the cure time is rather excessive, over sort of 4 to 5 hours in cold temperatures. Moving on to the sort of middle resin in our epoxy range, this is the 9204. It's a great alternative to polyester resin for liners that are sort of between ambient and hot cure, for example. So it has a pot life of around about 1 hour and 30 minutes at 25 degrees. That is increased significantly if we chill the resin down, and we can get 3 to 4 hours pot life at the lower temperatures with a very controlled cure of 2 hours at 50 degrees. It can be impregnated on site and generally requires quite a small installation footprint, because we can cure 9204 either with a small steam boiler or a small hot water boiler. Again, it has the same benefits as 9052. It can be used with our full range of drain liners for the dragging application, inversion. It can also be used with our flexible liners for applications where we have 45 and 90 degree bends. Again, the product is completely leak tight and has good chemical and thermal resistance. Obviously, following the presentation, should anybody want to ask any questions or would like the information on any individual resin, please do ask. So if we consider the strengths or the pros and cons of the 9204 again, as I say, it's compatible with a full range of liners, good chemical and thermal resistance. We can get thermal resistance between 60 and 70 degrees with the 9204 if we post-cure for an extended period of time. We get nice flexible working time. And what's great about our epoxy range is it comes in 2 pre-measured components. So even if you're impregnating on site, you at least have complete control of the resin mix. In terms of limitations, obviously we can't line 500 meters of drain with the 9204. It has a limited working time, but we can probably get 50, 60 meters of 150. If we chill the resin down, we can probably do 60 meters of 225 diameter rehabilitation using this product. So it's a little bit less cost effective than polyester. And it also is necessary, with it being a heat cured epoxy, to cool the liner significantly prior to reinstatement. This is absolutely essential so that we don't have a situation where the liner folds in after installation. Moving on to the most popular epoxy product in our range. RSM are the first people to have an epoxy resin WRC approved back in 2010. And the 9100-1 is that product. It's a specially formulated unfilled epoxy resin, which gives us a long working time and excellent heat resistance, in excess of 80 degrees if post-cured for 5 hours at between 80 and 90 degrees using hot water or steam cure. The fact that 9100-1 is unfilled means it's also suitable for use with glass reinforced liners, and for small diameter applications is absolutely perfect for use with our Ferroforce pressure pipe rehabilitation system. 9100-1 can also be factory impregnated. With an extended pot life, we can impregnate in our factory in Doncaster and deliver all the way across the UK, ready to site for the contractor to install. So minimizing your installation footprint and increasing the element of quality through a factory impregnation in controlled conditions. Again, if we can just take a moment to look at the strengths and limitations. As I've already explained, it was the first WRC approved hot cure epoxy resin, giving the contractor or the engineer the peace of mind that this has been through not only ISO independent accreditation and ISO independent quality control, but also a third-party quality accreditation, excellent heat resistance, great working time, and also fantastic adhesion to the host pipe. In terms of the limitations of the use of 9100-1, the liner does only have a finite amount of working time. With polyester, it is possible to store liners possibly up to 7 days. With epoxy, ideally, within 24 hours, the material needs to be installed after impregnation. Epoxy obviously is a little bit more costly, but you do get the added benefits of adhesion, no styrene, and the excellent chemical and heat resistance that epoxy brings. It's particularly good for areas where you've got high levels of hydrogen sulfide attack. One further limitation is the ability to impregnate and laminate epoxy in larger thickness or en masse. Epoxy is a volatile material when you are mixing it in great volumes, and so we should be careful to process it in as smaller volumes as possible and ensure that we are curing according to the manufacturer's recommendations. We can give you advice on the cure of thicker epoxy liners should you have those specifications, but it's incredibly important to do that so that we get the absolute maximum from the cured composite. We can also consider to add glass to the liner to ensure we meet the design characteristics whilst not increasing the thickness too greatly. I'm now going to move on to our Pipe-Aid silicate range. Pipe-Aid is the trade name for our patching product and our short liner repairs, and within that we have a vast range of silicate resins that can be manipulated for both short liner repair using glass fiber, but also for use with our range of full length liner reinforcements. The table within the slide gives an overview of the working life, gel time, and cure time of our whole range of silicate resins, and they are completely capable of being able to be mixed with each other to ensure that you get the optimum working life and gel time for each individual application. Silicate resin has absolutely fantastic chemical resistance to a range of different acids and alkalis, and also of an ambient cure product, the best temperature resistance. In terms of pure water, between 90 and 100 degrees resistance using silicate resin. It's also great for use in in-house applications, as it is also completely styrene free and adheres to the hose pipe. We see silicate used in applications anything from 50mm diameter in-house to 1.5mm diameter for large diameter patch repairs. The silicate resin and glass fibre is also WRC approved, so you have the peace of mind that it's been through, again, not only an ISO accredited quality control system, but also through third-party certification. Silicate resin can be used with our full range of liners, and it's particularly good for use with our flexible liners, again, because the viscosity and the fact that it has excellent adhesion properties means that it holds within the liner and forms a great leak tight finish for internal drainage systems. To give you a very brief overview, silicate resin gives us a cured composite with zero shrinkage, great strength characteristics for an ambient cure product, great chemical resistance, and no styrene odor. We can also vary the curing times and provide advice with that. We also supply an accelerant for use with PU silicate resin in particularly cold temperatures. Moving on to some of our more specialist resins. We offer a range of vinyl esters. Our stock vinyl ester is the L010, and generally vinyl ester resin is used as an alternative to polyester or even epoxy hot cure products when a higher chemical resistance level is required. Our stock vinyl ester has passed the notorious California Green Book approval, a pickle jar test, and is suitable for chemical resistance applications, generally up to around about 85 degrees with little consideration, but we can spec it to be used with a whole range of effluents that contain industrial chemicals which are potentially incredibly aggressive to standard hose pipes. Vinyl ester resin, to get the absolute most out of the product, must be factory impregnated and generally hot or steam cured to ensure that we get the very best temperature resistance. Due to the high elongation at break of our vinyl ester, it's also suitable for use with glass reinforced composites. So we get the absolute maximum out of the glass, and increased flexural modulus and tensile strength makes the product suitable for use with not only our ferroforce pressure pipe system, but also for very large diameter applications and chemical resistance applications. Once obviously we have impregnated the site the liner in a factory setting, it's delivered to site and usually inverted into the pipe using a sluice, scaffold tower or other pressure vessel, cured using a hot water boiler or steam boiler, both of which are available from RSM. The compatibility of vinyl ester is a little bit more limited than some of our other materials, but we stock an extensive range of polyurethane coated and polyurethane coated liners with extra resistance, extra passive coating for pressure applications, and also obviously the ferroforce material. In terms of just a very quick overview of the sort of strengths and limitations, obviously we've discussed some of these already, but we can do very, very long length installations depending on the pressure required and the drainage system. Anything up to 500 meters is not beyond the realms of possibility if we have the right curing equipment. Suitable for use with all heat and steam cured systems, great elongation, as we've already mentioned, and a temperature resistance that's generally 20 to 50 degrees higher in combination with chemicals than standard polyester resin. It's also relatively cost effective. It's much cheaper than epoxy resin and silicate resin, although it is a little bit more expensive than polyester. And it's also not really suited to ambient cure. Looking at further specialist resins and styrene-free alternatives as we become more and more concerned with our environmental impact of lining installations, we look at LED cure. RSM offer a bespoke UV vinyl ester, which is suitable for cure using several of the industry LED systems. Our particular chosen system, the Sewertronics LED speedy light system achieves excellent curing results with our LED cured vinyl ester. We also use this with a variety of different liners, which give shelf life between 2 and 14 days, meaning that liners can be impregnated at our factory in Doncaster and sent across Europe, across the UK for installation in the days following. We also have various other developments on the horizon with regards to UV LED in terms of patching systems and also systems which give us greater adhesion to the host pipe in epoxy and methacrylate form. And those of you that have tuned into the webinar today may be interested to keep an eye on the regular communication that comes out from our marketing department as to the new developments that we have in this regard. Styrene-free resin that is cured using LED is very flexible, holds in the host liner incredibly well, gives us great mechanical properties when used in combination with our MagmaFlex glass reinforced material, and is suitable for use effectively across the board of any diameter, really up to 300, 375 in the range. In terms of the pros, we've got a really fast, efficient curing method with a full background of data so that we can see exactly how the liner was cured, the temperatures achieved, the speed of cure. We have complete traceability of the curing process. Once obviously the liner has been impregnated, it can be stored for several days depending on the ambient temperature, and ensuring obviously that we keep it out of direct sunlight. In terms of the limitations of this method, we must be incredibly careful as to how we handle the impregnated liner. Obviously, the resin is sensitive to UV and LED, so it really must be kept out of direct sunlight during installation, if at all possible. And obviously, the newer technology is a little bit more expensive than our traditional ambient heat and steam cured systems. However, obviously with that you get a greater degree of speed and also a greater degree of knowledge about the curing process. The compatibility of UV LED vinyl ester is shown in the table here, and I'll not go too much into detail, but you can see that obviously across the board we generally have a liner or resin for most applications. And if there are any specific enquiries after the presentation, then please do address those, and we'll do our best to answer and assist you with any jobs you may have on the horizon. I'd like to thank you for listening. I'm just going to take a view at some of the questions that may have come in, and from there I'll try and answer those. If you do have any questions and I don't get through to answering them today, please do bear with us, and we can obviously answer all of the questions after the presentation. Just bear with me 1 second, sorry. The question here from Jeremy in terms of, has a WIS document been developed for CIPP lining applications? Absolutely, Jeremy. I can send you a copy of the WIS specification for lining and patch repair. The code is number 43404, and that has been taken into account in the latest ISO specification, which is 112964. I believe there's a 2018 version, but we can send you a copy of each of those following the presentation. To look at Tim's question from Green Day Environmental in Dublin. Tim, you're looking at patch repairs. What guarantee can we offer on the repair? Well, essentially, it depends on the application, but our mechanical property testing focuses on a 50-year life cycle. So as long as the effluent doesn't change in the domestic system, and it's been it's been accredited, it's an accredited system, then I would have no issue looking at a 50-year guarantee. It's quite happy to offer that. To look at the mixed materials life of same pipes when patching and CRPP applied. I believe that is the case, but I will drop an email to Mr. Garney just to seek clarification on the question, if that is okay. To answer Jeremy's question in terms of pressure rating within CIPP liners, CIPP liners can be designed to withstand pressure. Our ferro force system generally can be designed to withstand pressures of up to 12 bar. With a series of short questions, we can design liners according to those applications. In terms of the question regarding Regulation 31, unfortunately, none of the resins that we've discussed today are suitable for use in potable water systems. There are resins available across the world that have passed various potable water examinations. I don't believe there's anything Regulation 31 approved available, but by all means, we'll have a look into that for you and come back to you. I think that clears up all the questions. If there are any further questions, if you could please address our sales